So, do we want to go over the action items? No.
So no updates from Safe Transmute. I don't think there are any updates from Constaval except that the one PR landed. If I unwind, do you want to say anything here, Nico?
Talking about here. Yeah. So we had a big discussion, 2-hour-long discussion, where we tried to pull everything together. We made a bunch of notes, kind of narrowed out. This was Amanu, me, Kyle, and AC Fulter. And we are planning to turn that into something human readable now. And it looks like I scheduled our February design meetings. We'll get there. The only date that seemed to work for everybody was February 24th, so there it is. And we're hoping, though, to publish that and start talking a little bit faster than that, because that's kind of far away, and maybe we'll end up not needing it if we can reach consensus beforehand. But there you go. On the go on.
Go on.
I wasn't going to go into any details unless you want to.
No, just give a brief update.
So on the DIN trait stuff, I tried, after our meeting last time, I tried this fix where we basically declare that traits are not DIN safe if they have an impl that would overlap with the magic DIN impl, plus they have associated types, which is not exactly what I was saying about making things implicitly default, but I wanted to see if it would help identify what's affected. We did a crater run. I haven't gone through the results yet, but it's promising. Suggests there are a few 15 root regressions from a lot more, so that's good.
Definitely. This is the one taking functions into account, not.
What?
Is this the one taking associated functions into account?
Yes, it allows you to have an overlapping impl if it's only functions. It's kind of the idea, because that would be, with that I don't think you can observe the difference in semantics in that case. I'm still preferring to do the sort of default version that I talked about, forcing it to be considered default instead. But I wanted to, this was easy to code up, and I wanted to, it gave me some useful data.
Cool. No updates from the ground working group for now. I think there have been some updates on the links on the other side.
Yes, so yesterday, I guess it was yesterday, we had a little pair programming session, Hell Logic and I think Matthew was there and a few other people. And we started mocking up a lint. We're basically looking for type variables that fell back to unit and now would fall back to never, which appear as the type of a live expression. That's the thing we're trying to find. And we don't quite have that yet. We have type variables that fell back to one, not the other, or that will change, which appear as the type of any expression, which is a little too strong because it flags all over the place. But we had some ideas. That was as far as we got, and we have some ideas how to go forward. So I'm feeling pretty okay. Hopefully we'll get that going in a week or two.
Cool. Moving on to the triage. For PI issues, I think the usage of erroneous constant and replacing the fragile safety scheme is done. So I think that's just for the comparison now. So I think we can remove those. And there doesn't seem to be anything new here.
Yep. Okay.
So we can hop into the nominated PRs. We will skip the negative impulse for now and jump to the rest. And we can get back to that if we have time. So the first one is selectively disable sanitizer instrumentation. So here we have the PR adds a no sanitize attribute that allows opting out from sanitizer with instrumentation in an annotated function, says the code description. And your screencast is strange.
I moved it to another window and it did weird things. Hopefully it's working now. Or I moved it to another screen, sorry.
So,
I can talk about this. So I nominated this PR, selectively disable sanitizer instrumentation, not so much for its exact contents, but just to bring it to the awareness of the group and decide what we thought we should do. So what this is doing is modifying the support we offer for sanitizer integration. So in this PR 388699, we added kind of unstably experimental integration with LLVM sanitizers. And Chaparek added it, but since then, Team Yasku has kind of been working on it. And I don't know, it works as far as I know. It's documented in a few places. The reason I brought it up now is until now, it didn't really have any impact on the language per se, but this PR adds a feature-gated attribute that excludes functions from sanitization. So a sanitizer, in case you aren't familiar with the term, like transforms your code so that the binary also does additional sanity checks, hence the name. Sort of looking for, sort of like Valgrind, except that it transforms in the compiler itself and the binary contains the transform version. The main question I wanted to raise was, like, I'm inclined to land this PR because it's small and useful and seems to doesn't do much. But do we want to just leave it in this state? Would we like to start at some point encouraging this down some road to possible stability? That's the question.
So looking, sorry, go ahead.
You can go. You can beat me.
Looking quickly at the PR, it seems to have some interactions with inline. I think it shouldn't. So I think if we were to support this, I would like it to, like, in terms of language semantics, just be like a registration and nothing more. Then you can specify this formally as this attribute has no effect. Basically, it exists, but nothing beyond that.
I assume that would be I mean, that sounds right. I kind of think this is, in truth, only barely a Lang team issue in that it's more of a tooling support thing in this way. I don't think it would like be part of the language semantics.
Well, it's part of language semantics in the sense that it needs to exist.
It's in the list of attributes that you can add, right? And it would sort of be formally, it's a hint to the compiler that it could.
So, I think the PR needs to be adjusted a bit to not have any interactions with inline from my perspective.
Inline also has no effect on the language semantics.
Is your thought here central that your recommended approach would be that they should be specifying inline on the functions that they've written no sanitize on, and just have to and not have the, because the reason they've done this is to get the conditional behavior of not inlining only when you have sanitation turned on. And I don't know if there's a way to express that in the attribute system.
So when I scroll down to the diff, the last part I see is that there is a no sanitize inline always test, which says that cannot use inline always with no sanitize.
Why is that not, like, that seems good. So why would we not want that?
Well, that means that it has interactions with, so
there's some static verification required.
Yeah.
That's correct. But I mean, the reason for that is presumably that if it gets inlined, then you would have to propagate the no sanitize hint to the caller, essentially. Like,
well, inline is a hint, so you can just ignore the fact that.
But inline always isn't really a hint.
Inline always is also a hint. It is not required to inline.
Is it?
If it's recursive, for example, it cannot be inlined.
Inline has no effect on the literally does nothing in the language spec.
My point is both of these do nothing in the language spec. The only
Right.
the only thing in the language, depending what you want to say, I mean, but the thing in the spec would be that there's some rule that says you can't combine these two attributes or something.
Right.
This is actually, that's important then, because what I was actually asserting was you needed to be able to combine the attributes to accomplish, well, no, I want inline never, I guess, is the thing I needed, because the thing I'm trying to point out is in the middle of the diff, they have other interactions with inline they've added. In particular, if you have the sanitizer turned on, they try to actively avoid inline function marked as no sanitize, because they don't, if the instrumentation is turned on for the caller, they don't want the no sanitize routine.
So that's dynamic semantics. I think it's not.
My point is, if you're asserting that you don't want interactions with inline, and maybe you only mean the inline attribute, if that's what you meant, then I misunderstood. I thought you meant you don't want any interactions with inlining in terms of what the compiler does.
All right. So,
well, it seems like it has more interactions in the type checker as well.
It seems like we should at minimum write up the rules. That's like probably the next step, and we can revisit this when we have it. Like, it's worth writing up. It's worth writing what these interactions are with inline, so we can, like, right now we infer it from the code, but there's no write up. And I would prefer, before we land this, that even if it's unstable, there's a link from the tracking issue to some. We can extend. I've been encouraging Team Aska to extend the unstable docs, for example. I think
it feels like this has the same interactions with inline that the like optimized attribute does, because this is just another case of something that we can only really do at a function level.
I think that's right.
Well, the optimized attribute doesn't have any static semantics other than existing, as far as I know, unlike this one.
What is the static semantics of this?
Well, it has if you check type check collect.
I mean, we're not going to specify the sanitizer behavior.
Yeah, because the sanitizer by definition does nothing on a working program, on a valid program, right?
Yeah.
But you are talking. I think you are talking about the dynamic semantics of the thing, not the type checking semantics.
That's right. Sorry, I'm confused. I think what Scott was saying is anything that operates at a function granularity is going to probably wants to interact with inline all the same way. Like, it doesn't make sense to inline things where you wish to exert control, but you can only do that control at the function granularity.
So what I would do instead of adding like type checking semantics to this, which interact with inline, I would just ignore inline, like as if it wasn't there, suppress it basically.
All right.
So could I say that your thought is that you want the diagnostics about inline to be a quality of implementation issue, so that it would be a warning or a opt out of a lint or something, as opposed to it must be an error?
Yes.
I see. Okay.
I think it shouldn't be part of the language specification. That is.
Okay. I don't have a strong opinion about this, I guess. If I do have an opinion about, I think we should tell the user that it doesn't make sense. Whether we do that through a lint and we just make it make sense, or we do it through an error, I'm indifferent about it.
That's fine. I think.
Okay, I'm good with that. And I will, so let's say resolve.
So one question, would this have any interactions with Miri, potentially? Because Miri feels like sanitizer, sort of. Well, it's more, but
I think Miri can decide that.
I don't think it has any real impact on Miri. It doesn't modify the mirror in particular. Miri is a sanitizer as well, but
sure. But like, just like this as an attribute name, possibly you could add new sort of sub flags to it, which would interact with Miri somehow.
plausibly. Yeah.
Maybe that's something for Ralph and Oliver to think about.
Yeah, I see what you're saying. Like, we could have a general category of depending on what kind of sanitizer you're using, including Miri, there's, yeah, maybe. That's an interesting question. I think it's not worth the energy now, but I would like us to. It would be cool if we offered sanitizer integration in a sort of nice and official way. I think like it'd be useful for people. And I definitely think it should be an important part of our unsafe code guideline story longer term. So.
This might be a bike shed, but like, are people cool with how this is doing like it's a no sanitize attribute as opposed to having something like a general purpose sanitize attribute that has like sanitize never or something like those lines that would be more analogous to how inline and I think optimize go?
I like that, sanitize never. But there's no other value that makes sense. Sanitize always or something.
If you have sanitize never, how would you express the like sanitize address never?
I was assuming like, I guess it'd be
well, that
sanitize address comma never or something like that. It's a decent point that there's more structure here that I'm not acknowledging.
Well, I feel like it works the other way, actually. That doing sanitize never gives you have parentheses already. We kind of have room to introduce structure in there.
So you mean never, and in the never you can say blah and blah and blah.
Yeah, you could do a lot of things. But
no, I like that. I think sanitize is more general.
Right. It gives us room to just add whatever. Whatever thing seems to make sense in the future.
Yeah, I think Philip's suggestion is good.
Okay. So we're resolved on these 3 points.
Should we start with Felix's suggestion initially?
That's what I'm suggesting. Or I'm planning to mention that to Team Yasko and see what they think.
Cool.
I can write up a comment summarizing this feedback. I think, at least I believe I understood this conversation.
Okay. Yeah. Let's put that up here.
Okay, let's move on. We're 24 minutes in.
Next one was the correct inference of primary, right? So this is a little interesting corner of our type checker that I had totally forgotten. So at the moment, when you have a binary operator, that requires us to prove this trait obligation, like something like this anyway. I forget if this is the right name of the associated type, but in general, that's how we type check it. However, we do have a little bit of a hack in there because we had this problem where if you had something like this, the only constraint that the user is given on the types of 22 and 44 is the result should be usize. And the type checker doesn't propagate, at the moment at least, backwards constraints from the result type to the input types. Actually, you gave 2 constraints. You said this has to be some type is valid for an integral, literal, and usize. And given the set of impls we have, that actually is sufficient to narrow it down to that all 22 and 44 must also be usize, but the trait checker won't prove it. So what we did was we had a little hard-coded thing that basically said, okay, well, we know some things. We know what impls are in the standard library, and we will hint to the type checker to move along. And in particular, if both arguments are integral types, and then we know that the result must also be an integral type, or must also be the same as those. That A and B must be equal to the result type. So unifying that gives us the constraint we want on 2 and 4. And if we didn't do that, those would wind up falling back to I32, and then you get an error because there's no impl of add from I32s. So we added that way back when, I don't know, pre-10 or something, when we're trying to add these traits probably. And What this PR does is to extend that check slightly because so that it works not only for just adding 2 integers, but also adding references to integers, which there is an impl for, but we would fail the type inference in the same way I described.
This is for floating point numbers as well.
It's also for floating point numbers. It's fixing a long-standing old bug that pointed out that the behavior was sort of surprisingly inconsistent, where you could write like so, but you couldn't write like so, even though it would work if you wrote F32 explicitly. So the question is, I've already encouraged us to write some notes in the reference. I think Barkhor left notes on the bug, since there is no material in the reference like this right now. But yeah, shall we land it? I'm inclined to land it, I guess. It's no worse, but I don't have a strong opinion.
So there is already a special case.
The special case exists. It's just extending it to cover ampersand.
So 2 questions about this, because I'm concerned about opening up a hole here. If you were to write ampersand, let me actually type it out. Hang on.
Okay, so this first one works the way that the code is written. By works, I mean it gets in, both of those integers get inferred to usize. Basically what the code is doing is saying if both the left and the right are either integers or references to integers, but independently from one another, then the integer types underneath have to agree. However, this last one that won't compile. For one thing, the result type of this expression is usize. We actually I don't think we even look at the output type. So we're only looking at what is the types of the arguments, and these would be, we would figure out that the type of 22 and the type of 44 and the type of X all have to be the same, but we would get an error because that cannot be an ampersand, a reference type. It can only be an integral type.
We could make this work, I think, by some sort of coercion by looking at the expected type. But
I'm not suggesting we should. I'm trying to understand, like, so does this only happen for numeric literals, or will this also work backward if you have things like let A without any type equals 22, and then let X usize equals A plus 44?
It'll work for that case as well, because
it will work backwards and say A must be a usize?
I'm not actually 100% sure, but I think so. We can test it.
Okay. I'm mostly concerned about introducing the additional variability here of the ampersand case that suddenly means it's no longer fully unambiguous what it might be, and I wouldn't want there to be some kind of ambiguity here of, well, now A could be reference to usize or it could be usize.
So it does work in that case, as I sort of expected, but just wanted to be sure. But you can see that it, so what happens here in this case, the reason I hesitated for a moment is we create a second, we have 2 type variables here, the integral type variable and this one, that is the type of A, but they get unified together. So then when we come to ask what is the type of A, we wind up with that integral variable and we see 2 integral variables, and so we force them to be the same. And so you can see that if we introduce an ampersand, since this PR is not yet landed, we no longer recognize that as an integral variable because now it's a reference. And so we don't force them to be equal, and so they fall back to I32, which is why we're getting this error.
What happens if you, with the PR, what would happen if you would remove the expected type usize?
Oh, well, then everything would fall back to I32.
Right, but it would still work with the,
Just like
with
here.
the reference.
And it will still work with the reference because there exists an impl from I32, ampersand I32 to I32.
I think it would be good to add those to the test.
These,
Yeah.
a case like this.
Yeah,
Yeah, okay.
and without the expected type as well. I think.
In general, this seems like a reasonable step to me. I just, I know that every time we add an interesting new corner case to the type system, it seems like it's a coin flip whether the next release or the release after we have some really obscure type system bugs that we have to deal with that we just get.
This is just for the arithmetic operators, right, Nico?
It's for yeah. I'm not sure if it's definitely not for the short circuiting operators. They have a different path. And it's not, it might apply also to shift in some ways.
It does. It's built-in up, and built-in up seems to.
But it won't do exactly the same rules. I mean, the reason I was hesitating is it does trigger for shift, for example, but it's not going to require that. We don't require that the thing you shift by is a U size.
So it would be good to test the more. So this is just plus. It would be good to test some more categories.
Yeah. Also add tests for other, sure, binary operator categories and cases where the expected type is not provided. Okay. That's good.
But other than that, I think we could do FCP.
All right, I'll start FCP. Okay, we're resolved on this. Let's move on then. I'll leave the comment because I'm reviewing anyway.
Stabilize repro transparent on enums. Check your boxes if you want and stuff. Specifically fix if you check your box, then we are in FCP.
Yes, I'm reviewing. Okay. Repro transparent enums. Okay.
So repro transparent enums, specifically univariant enums, behave exactly the same way as a struct would with repro transparent. And we are not stabilizing for unions right now because they have more interesting questions.
Oh, okay. I think I already checked my box. The rest of you.
Yeah. Fix specifically.
Yeah, I checked mine now. My misgivings about transparent obviously don't apply to. I mean, it doesn't matter for this case. It's more general.
Okay, I was gonna come and shame people, but they're not even here. All right. Actually, before we do this, Central, I wanted to go. I don't think we talked about the February schedule, did we? I wanted to float this out that I had earlier today tried to plan out design meetings for February. The reason I skipped to February is that next Monday is a holiday here in the US for a lot of us. And after that, Felix and I at least won't be here because of the Mozilla All Hands. This was what I had written down. We talked about wanting to do a specialization infomercial where we just kind of go over the history of specialization and bring it all. I talked to Ralph about doing some unsafe code guideline stuff, and I think the unsafe cell bugs that have cropped up are a good choice. This would be the.
I was actually going to go over to the mutex unsafe cell bug.
That is
right
the
now.
one, I think, right? That's what's all. I just wanted to. I mean, what reminded me of this was that I had scheduled these meetings, and lastly, the FFI and wine working group. I also think we need to plan our all hands meetings, but I started a topic in Zulip where people can throw nominations for that because I want to do that faster than a meeting anyway. We can return now.
Thank you. Let's see. Yeah. So moving on to the nominated issues, we have mutex and arglocker and sound in the presence of discriminant deletion. So that's a mouthful, but basically consider a type like option of cell of some type. Let's say a pointer or something. In this case, what would happen is that you the representation of option of the cell of a pointer would be the same as that of not having the option. So it gets niche optimizations.
Is this the example?
Yeah. And for types which are not for threading and stuff, like cell, this is not a problem, but it's a problem for mutex. So we have the sound as well there.
Basically, because in case it's not clear to everyone, that in order to determine if this option is some or none, you have to read the value of the bool, which other threads might be accessing, which is therefore a data race, because you don't acquire the mutex before you do the read.
Yeah, a niche needs to not get pushed through the mutex either inward or outward, because everything that should be protected by the mutex has to stay protected by the mutex.
So Robin made the point that this niche optimization can be used for cells. That doesn't occur that often, so it's not super useful. There is some sort of how should we say, orthogonality in having unsafe cell do one thing instead of doing many things, but this is a bit on the surface. It's not a very deep having it do. I'm explaining this horribly. Do only one thing and one thing well.
It feels like there's. Go on.
Ralph also made the point that this having unsafe cell interact with niches is problematic for formalization of the operational semantics of the language.
Yeah, I feel like this has come up a couple of different times, and there should be kind of a generic way of allowing like a directive we can give to the language that says this type is opaque to niches, and you should never use bits outside of this data as the discriminant for data inside this, and vice versa. Is there a way we could have that be generic rather than?
Felix suggested this in two ways. The first one was a wrapper no niche, and the second one was to have like a wrapper type which would inhibit niches.
It's worth noting.
No niche of T something.
A union also fits that definition.
It does, yes. We should, if we're going to do it with a repr, I would suggest that we're more explicit about not passing through niches as opposed to not allowing niches inside, because there's nothing wrong with, for instance, mutex of option of bool using niches to be the same size as mutex of bool. But
I think that's
option
the idea.
of mutex of bool needs to be bigger than mutex of bool.
So
I want to raise one other observation before we go on, which is just that it seems like what's at play here is very similar to the problems around ampersand unsafe cell and the referenceability, at least to my mind. Specifically, we have these bugs where if you have an ampersand unsafe cell, or atomic cell, or whatever it's called. The point being that when you kind of have multiple threads at play, and so, for example, in an arc, when one of them decrements the ref count, you don't know that the arc won't get freed by some other thread before your function is returned. And here again, it seems like the key distinction between cell and mutex has to do with threading, right? So unsafe cell, we kind of used it for any shared mutable thing which may or may not be shared across threads and so forth. And I think that might be the...
This applies to ref cell, which isn't send, or isn't sync. Because you can send the mutable reference you get from borrow mute.
It applies to ref cell in what way?
In the sense,
yeah, okay, I see, yes, okay. Okay, maybe I'm wrong. That's interesting.
So,
can you spell that out? Whatever. I'm sorry, I did not follow whatever that interjection was there in the context of what Nico was saying. Do you mind spelling out?
But I'm not, yeah, I'll spell it out. I'm not convinced that invalidates what I had to say, but what I was basically saying is that the key has to do with threading, but what Matthew, I think, was pointing out was that if you have a ref cell, it's frozen. I mean, it's not, the ref cell itself can't be sent, but you can get a borrow mute of the ref cell. And now you have an ampersand, you can make this into an ampersand mute, and then you can like run that on another thread, for example. And so now you are mutating the contents of this ref cell from some other thread. And hence, if you like inspect the ref cell here to see if it's none, this would be like an option ref cell, I guess. Now you would have the same data race. But I think maybe what all that says is that a ref cell wouldn't use, a ref cell would also have to use the like maybe accessed in parallel version of unsafe cell. It might be that only cell is the only type in the universe that can avoid that, actually. Maybe cell is a primitive in this sense, but.
So beyond having a no niche representation or using a structural union, etc., there was the suggestion that we would simply inhibit unsafe cell from propagating niches, which is, I think, Ralph's suggestion.
I'm in favor of that. I think because we have to assume, like the whole like design of the language thus far has assumed unsafe cell means this might be getting mutated by other threads. That implies certain things, and one of them is that you can't be poking at it for things like niches. And if there's other code that's known not to be accessed by other threads, we need a way to say that.
So just to read an excerpt from what Ralph said on Zuit, he said that, note however that it turns out that unsafe cell having niches means that it's really hard to define what that one thing is. A variant of stack borrows that currently models the one thing unsafe cell does with support for exposing niches might be possible, but I think it will require things I would like to strictly avoid, like ghost state that recalls the actual Enum discriminant in some magical place, even when in memory, etc. So it's sort of like the active union variant that he really didn't want to have. And that seems bad and not worth. So before you wrote that, I was actually not in favor of inhibiting the niche, but after you wrote that, it feels like it's not worth the cost to the formal model of the language for what might be very niche benefits. But there's one thing that's worth noting, and that is that we've sort of, because unsafe cell is record transparent, we've sort of ish promised that it should interact with niches. So we would sort of be backtracking on promise we've made. But I think we could still do it.
How?
And I think we probably should.
I'd like to point out that it's really hard to find the docs in Repr Transparent where it says anything about niches. So I still am questioning the statement that we promised very much at all. I do agree that there has been mention of this, like the interaction with niches. I've seen Robin Krupp's statements. I think I made statements in places like on PRs and stuff stating that Repr Transparent means the niche is exposed, but it's very hard to find any of that in the reference documents.
I would also say there's a soundness whole, like these two things are in conflict. We have to resolve it some way. But
yes. Well, specifically if you check the Zulip discussion, there is the PR where we made some things apply safe.
Right, I acknowledge that. Yeah, I assume you're saying this just tell the rest of the Lang team. There is a particular option unsafe cell of ampersand I32 is now considered FFI safe.
And that one is observable, but I think Nico's comment around, okay, this is a like soundness fix. It's a reasonable thing to do. Is good. I think like it is a breaking change. I think, but we could still do it.
Okay, so specifically, what the concern would be that something like option cell, not I32, but bool. What would be an example that this is like FFI safe and it would now change size?
Yeah.
Yeah. Okay. I'm not.
It would change size and be no longer FFI safe as well, right? I think the FFI safety, the lid would just start saying it's not FFI safe, right? Am I wrong about that?
I think that would happen. Yes.
Okay. Oh, link was buggy. We just didn't know it.
There might be ways to implement this so that unsafe cell is not FFI safe, but option cell would be. There's things we can do to try to address the cell case if we really wanted to, but it's questionable whether it's worth it.
I mean, I feel like, yeah, we can start by establishing soundness, and if we want to, it's not out of the question that we restore some way for cell to have niches. But
if we do that for cell, probably we would get all the drawbacks that Ralph was talking about.
I'm not. Yeah, I would like to. That would be interesting to ask Ralph.
Yeah.
Personally, I think we won't have to, so it's probably not that relevant. But
right.
Let's move forward.
Sounds
well. Are we resolved then? Should we?
I feel like there is no one saying that we shouldn't go ahead.
Yeah, but the only person I thought was saying that was Robin Krupp, and then I saw very recently that in fact Robin Krupp said we is definitely not in favor of preserving the existing behavior here.
Yeah, and me, but I changed mine. So it seems like we are resolved to make unsafe cell inhibits niches.
Okay. Somebody should.
Nico, maybe.
Sure.
Cool.
I've started working on a branch to actually implement this, so I'll steal the work there.
What's the next thing?
Pattern errors are too imprecise and should be removed in favor of a mere bar checker. Actually, Matthew, you could probably talk about this one.
I guess. So basically, in the past, we've had a bunch of restrictions around matches, some of them to catch various borrow checker limitations. This is the last one which doesn't have which isn't either removed or have a feature gate to remove it. I did a bit of research about where this was created and why, and it's as old as binding remove is, and it's from the era of everything being undocumented.
I remember this. Yeah.
Are there any soundness reasons for keeping the error?
So can we just say exactly what this is? We're talking specifically about this example, right?
Yes.
And in particular about having a single like variant that is partially moved out of and partially referenced into.
Right.
Yeah.
So you are binding by reference and by move.
I mean, the reason it was like this is because we couldn't cope with the fact that you would have to free the first half, but not the second and stuff like that. It just seemed too complicated to think about.
Right, but now it should work with the specific case.
Right, now that's not a particular problem.
Right, and so this should
What would
be
this
sound.
do otherwise?
Otherwise, what do you mean? And today it gives an error.
Yeah, that's what I'm saying. Today it gives an error. What would it do if it doesn't give an error?
A would be moved. So A would be a variable that goes out of scope at the end of this block and gets freed. B would be a reference into F, which does not get freed. Like F doesn't get, the remaining half of F doesn't get freed until we exit the function.
Consider if you didn't use pattern matching and you just said drop F 0, and then you took a reference to F1, which should have the same effect.
So what happens here if F has a non-trivial drop logic?
F does have a non-trivial drop logic. I mean, F itself? Well, wait, do you mean if foo has
What
a
happens if
drop
struct foo
limitation?
does? Yeah.
An error.
Yeah, that's definitely an error then.
That's separate. You're not allowed to move things out from a struct which has a destructor.
Okay, that's the missing data that I didn't have. Okay, so this would only ever apply to a struct that was effectively a simple struct with no drop logic.
I mean, there's drop logic on its parts. Its parts do have drop logic, like the
Sure, I understand. But if you move out of, if you moved out of F.0 and you don't move out of F.1, then later at the end of this function, F.1 will be dropped.
Yes.
And also and also after this match, you can have subsequent matches on F that ignore the first component and use the second, right? That's another feature of this once you make this change.
Well, except that underscore does
a valid first field and a valid second field.
Presumably underscore does a fake read in match, so you would have to use a let binding instead for now because of the bug.
This goes back to that conversation we were having earlier, I guess. I don't remember what the current status is there.
Well, I think Matthew would know, but
I don't think underscore does a fake read, but there may be a fake read on the discriminant as a whole that might give an error.
Right. Well, it results in underscore not having the no effect on the base.
In any case, I'm in favor of removing this limitation. This was like part of the dream of an old borrow checker handling these kind of things uniformly.
But so from an just a quick implementation question, is it just removing the code in check match? Presumably there is. Do we need to make any adjustments in the bar checker itself?
We shouldn't.
Cool. Then I could fix this like in an hour.
Oh, you got to add loads of tests, but
yeah, add the tests, right? Update tests, add new ones. Woo!
Of course. Of course.
Okay, so resolved. Do it.
And Central will make the error. Well, who wants to review this, Felix or Matthew? Both.
I don't mind reviewing this.
let's see. Should we move? We have 4 minutes. I think that's too few minutes to talk about the negative impulse. Is there anything else we should discuss?
I'm assuming that's more likely to be successful than taking 4 minutes to discuss pin unsoundness.
Wait, what was the alternative? Sorry, negative impulse, is that what you said?
I was saying I was saying that 3 minutes, or
Yeah.
I said 4, but 3 minutes is not enough.
I say we end the meeting. I'll leave comments on the PR. But
Yes.
I have to read
Sounds
it.
good.
I didn't read what you wrote yet.
Yeah. But some were just like implementation comments, and some were like flagging.
Yep. All right. Thanks, everybody.
Thanks.
Bye.